everyone. Thank you for joining this webinar. This is Sunil Kumarji. I'll be a moderator for the day. And this webinar, I think most of you have registered over the last few weeks. And we've been basically sharing this on various social media platforms. This webinar is basically for those of you who want to understand what lies beyond the regular connectivity of Wi-Fi and wired networks when it comes to the factory automation and Industry 4.0. So largely focused on Industry 4.0, we are trying to today discuss and kind of debate about how private 5G makes the factory robotics more flexible and fail-safe. And in order to do that, we are basically inviting you here from various industries, from manufacturing industries, from the telecom space, where you as manufacturers can use private 5G to run your industrial robots like your AGVs and AMRs, your automated guided vehicles and autonomous mobile robots with ultra low latency and also with almost zero downtime, right? So basically avoid collision detection, have collision detection in place and flexibility to, kind of configure your assembly line, in a very quick time frame, right? So what would take you typically months to do would basically take a few days to set up and run this setup. So manufacturing typically is the focus in terms of our session today, in terms of the connectivity aspects as well. And today we will be talking about how we will eliminate these Wi-Fi bottlenecks for our robotics, understand why interference and latency aspects which creep into the network and the security aspects as well make traditional Wi-Fi a very weak foundation for our high precision robotic control in with ultra low latency requirements and also using a very coordinated automation requirement as well, right? So we want to make the factories and the robotics in the factories fully flexible, fail safe in terms of their operations, and also ensure that you don't have to rip and replace your existing equipment, and you could use standard Ethernet and common protocols to be able to, with required very, very limited or no hardware redesign as such to connect to your thing. So we also bring in the foundation for AI, the digital twins, and the predictive maintenance in ensuring that your factories and the assembly lines are up and running. This could not necessarily be applied only in a factory setup. It could be applied in harbors, ports, in the airports, in the the railways business, and also in the mining industry as well, right? So today on the panel, I would like to introduce to you Abhijit Chaudhary, who is the founder and CEO of Niral Networks. We have Saravanan Bhaskar, who is there from FANUC India, who are an expert company in the areas of robotics and creating precision robotics as such. He heads the robot expert team at FANUC. We have Vibhor Gupta, who is basically the manager for robotic applications and AI at Bajaj Auto. And as for me, I have been in the Industry 4.0 space since 2021, where we've been working with Nokia in the areas of the verticals like manufacturing, oil and gas, energy segments, and also in the transportation and railways as well. And with several startups in the past who have been in the mission critical push to talk and push to conference communication setup as well. And so we can just get started and move forward very quickly in terms of because we have a limited time to address all these questions and take the discussion forward. We also invite the audience to share their questions in the Q&A so that we can basically then look at how do we take that also forward, right? So we would try to answer most of your questions as far as possible. And if it's not possible, we'll always email you or respond back to you, right? So we're looking at the complete 5G standalone core, indoor, outdoor radio units, all these other aspects which will be covered as part of the session today. So my first question goes to Abhijit. Or rather to the entire three of you here. So what bottlenecks do you typically see when it comes to the private 5G networks, when it comes to addressing the traditional connectivity solutions like the wired networks or the Wi-Fi and the public 4G or 5G networks, right? So can you elaborate on this connectivity paradox that we have basically seen, right? So over to you, Abhijit, maybe, and then Saravanan and Vibhor in that order.
Yeah, sure. Um, Thank you, Sunil. I think good morning, all of you. So, yeah, I think that's a very pertinent and important question, right? Because traditionally, we are used to using Ethernet or Wi-Fi in our office, home office. But when you talk about industrial sector and the kind of you can say the changes, disruption which is happening there, where digital twin AI is coming for industrial automation, basically how to make things more autonomous and use of robots, which is also a theme here. What we see is that there is a requirement for low latency. There is a requirement to cover the entire area, and also there is a requirement that things are done in real time, right? So to enable those things, I mean, let's see what are the kind of challenges. Like things are moving, right? Like the robots are are moving, or even if you have static robotic arms, you may have to change its movement or to another place. So the recabling. So traditionally, in any OT kind of environment, industrial environment, things are mobile or moving. So having wired network is a huge challenge. And I think Bivor and Saravanan, who come from that industry, will share more details on that. Now, the other part is Wi-Fi. So what Wi-Fi or public 5G and then private 5G, right? So coming to that, when you talked about Wi-Fi, Wi-Fi is traditionally built for IT applications. Say they work on a principle called CSMA CA, which is the MAC protocol uses that. That means they sense the carrier, the network, and if they try to avoid a collision, right? So it's the protocol which is used is basically not really designed for real-time applications where whenever you want resilience and quality of service, you cannot give it in a CSMS CA kind of network, right? Because what happens is that when the number of devices increases, then when you try to sense the network and try to send a data into the packet within that network or the Wi-Fi network, there can be a collision, and then again you have to avoid and send the data after some time, right? So traditionally, it is good for IT kind of application, but when you need real-time precision and with high quality of services, then it is not great. Then when you come to public 5G and private 5G, right? Public 5G, you may hear about a lot of cybersecurity attacks which are happening. The requirement of real-time communication, which are kind of very difficult to give in a public network because the data is going to a third party in a public network. On top of that, you cannot ensure that you can give real-time or low latency communication because you are dependent on the external public networks latency, right? It's not within your control. That is where private 5G can play an important role, and because it uses 5G, which uses a centralized scheduling algorithm, which ensures that every device gets its own chance to send a data, and it is guaranteed. It's not non-deterministic, it is deterministic. So that's why 5G as a technology is very well adopted for like resilient communication. And to ensure low latency and security, you create a 5G network, but within your factory, right? So that ensures security, cyber security, resilience, as well as ensure real time low latency communication, because data is within your control, within your network. The SIM which is given is private SIM which works within only your factory. So I think those kind of things, and also the handover in 5G is controlled in a centralized way. It is not device dependent, so it is quite seamless compared to Wi-Fi handover. So these are technically the reasons where we see that private 5G can play an important role on industrial automation, industrial autonomy, and robotics.
Thank you, Abhijit. Thanks. Saravanan, would you like to add a few lines?
Yeah, I think Abhijit has put up a pretty proper benchmark on what why it is required. So basically, if you see, the factories are becoming smarter now. So we have a lot of connected robots, machines, AGVs, cameras, sensors, AI systems, everything. Then before we didn't expect this much of things are going to be in a shop floor in the manufacturing sector. So this is where we think that the the private 5G adds value to it. It provides a dedicated network for the factory, which can give a better control over performance, security, the connectivity part of it, the one latency, about the latency which Abhijit was also speaking about. So this brings a lot of things to it. So the connectivity paradox is pretty simple. We have more connected device and more data than before, but many factories know they still struggle to use this data in a very effective manner. So the data exists, but it isn't always available where and when it is needed. So this private 5G helps bridge the gap by providing a reliable communication platform within the machines, like machines, robots, edge computing, the enterprise systems. So this makes a lot of things different. So more than it's more than connecting the device. We see it as creating a small ecosystem within the factory. So that's my view on how 5G is going to take it up there.
Thanks, Sarvan. Over to you, Vibhor. Any
Yeah, very well
closing
summed up
comments from your side?
by Savan and Abhijit already over why private 5G and why we are shifting from this traditional wired and Wi-Fi networks to wired 5G. I just want to add one line over it. Like, as everyone said, that private 5G provides all low latencies, reliable, deterministic communication needed for all these robotic AI systems. While Wi-Fi is connecting the devices, private 5G is basically enabling the coordinated autonomous operations at factory scale. So this is what the private 5G is adding on to top of Wi-Fi and what traditional wired networks are. So yeah.
Thank you. So we talked about the technology differences between Wi-Fi and 5G. Abhijit shared some of that and how 5G becomes a key enabler for the industrial applications. We also looked at the devices, the number of devices that are getting connected. See, industrial setups typically have evolved over the last 50, 60 years, right? There are physical factories and there are digital industries, and there are physical factories and physical industries, right? So many of these devices, they don't really connect to the Wi-Fi, and they're not enabled to do that they're not basically having the capability to do that as well, right? So these are some of the challenges that we'll possibly face as we evolve and bring in automation in every aspect of our industrial network. Today, most of the networks across the globe are industrialized, and we have seen more and more of them in India also using 5G and standalone 5G or private 5G, basically to look at how this can be addressed as well. So Saravanan, can you just quickly share a few details of the recent white paper that you published between FANUC and Niral Networks on private 5G for industrial robotics? What does that cover, and how did this robotic system framework connect to the Niral OS or Niral Networks OS system using 5G?
Yeah, so basically it's all started few years back when we started discussing about we have been working on all with Wi-Fi and LAN and things like that. So why the robots or things cannot talk or communicate via 5G network? That's the initial start, and then we met Abhijit and we started doing it. So then we had the complete setup done at our technical center, development center in Bangalore. So this white paper is just it's just an outcome of the proof of concept which FANUC India and Niral Network did it together. So this is basically the evaluation on how 5G can support industrial robots in real manufacturing environment. That's our key goal on why we wanted to do this.
Right.
So this we validated whether the 5G could provide reliability, low latency. In fact, we all had this doubt from FANUC. We had this doubt of whether this latency is going to be a big concern over there. So and the security measures of it, because we do have robot controllers which are cyber security certified, but we are not sure the network is certified enough, whether the network is good enough to hold on to it. So
Right.
from the integration perspective, the robot controller was connected to the 5G modem, which again which is part of our neural networks team. They provided it, and it communicates directly with the Niral OS private 5G network. So that's the core brain of neural network which they use. So the communication passes to the radio access networks which is an on-premises Niral OS 5G core, which we had it here. So we connected multiple robots to that, and then we ensured that we did within the factory network. With, as you know, the real manufacturing factory networks, there are a lot of other equipments, other disturbance noises to it, but still we could able to secure and have a low latency connectivity. So while keeping the operational data inside the enterprise itself. So that's the biggest breakthrough which we could able to see it over there. So the important
Right.
point is that we did not modify the robot control architecture for any of these things. The robot continued to use its own standard industrial communication interface, while the private 5G acted as a communication layer to it.
Right.
This makes it no easier for manufacturers to adapt 5G network without no redesigning much of a thing. Because the existing line, if you're going to tell somebody to change, modify the control system or the entire structure, it's not practically viable for anybody to know put it across there. So this
Right.
was no one of the key thing which we thought no it's very good for no at addressing here. So the results of the proof of concept, no, which we demonstrated approximately around 5.6 milliseconds of latency with 700 plus Mbps downlink throughput.
Right.
And the network time which we tested, it was 100% network uptime, which we tested near to know 8 hours of time, which you could able to have a very consistent output of throughout it. So more importantly, this 5G network didn't affect any of the performance of what the robot was already doing, which is
Hmm.
very necessary for any system as such. So
Right.
for us at FANUC, no, this is the biggest takeaway for us. For simple, again, we provide the industrial robots which can operate more reliably. So wherein we also need to have an enterprise controlled, more reliable network as well. So this opened the door for us. That's the overall brief of what we why we did and what we took away from this study of proof of concept and we made as a white paper there.
So you're able to kind of interface with the Niral OS and apply its 5G stack
Yes,
without having with standard TCP IP interfaces, is what I
regular,
understand.
regular standard
You,
TCP IP we could able to
so
do
you
that.
don't need to connect the ROS 2.0 or some of that stuff, which is
Got
basically
it.
the next stage, hopefully, right? So
Yep.
excellent. Thank you for that, Saravanan. And Vibhor, would you like to kind of share some real world manufacturing use cases where private 5G kind of unlocks the capabilities that were previously difficult or impossible to achieve, right? So what do you see there as the potential areas?
See, the shift is happening because
Right.
we are moving from traditional wired networks to the Wi-Fi to finally the 5G networks.
Mm-hmm.
So this shift is basically from wired to we were having automated systems to finally autonomous systems. So like in automated systems, like if I can give example of my real factory floor of Bajaj Auto, where we have a robotic assembly line of say 70, 80 robots and 500 plus devices and traditional wired network of say 5,000 meters of the cables being deployed. So
Wow.
the real challenge that we were facing is to reconfigure the line to add the flexibility. If I want to add or delete any device, like there are already 500 plus devices, we want to, with all new models coming in, if you want to reconfigure the line, the whole
Mm-hmm.
wiring needs to be changed. So there, the private 5G plays a real world example where without wiring and all those stuff, you can reconfigure the line, make it more flexible, and slowly make it more autonomous with all ultra low latency, redundancy, and deterministic controls. So yeah,
Mm-hmm.
this is one of the biggest thing where flexibility and scalability comes in picture. Apart from it, of course, to have those systems in high resolution AI vision cameras, a fleet of AMRs, all these to work and synchronize in real time. These are some cases of the shop floors which private 5G helping in to cope up with. Yeah.
And so if you name a critical enabler for the whole private 5G, what would be that for the next generation factory robotics, basically beyond this Wi-Fi and wired networks? If there's one or two things that you would see as a critical enabler there.
Critical enabler, I think, is like I said, the flexibility and the scalability part,
Right.
which is the biggest enability which we are achieving through 5G.
Mm-hmm.
Uh, in traditional wired networks, again, the lots and lots of wiring, reconfiguration, and then again programming. All those things are involved, which now at with private 5G will be able to achieve pretty much faster in without actually, which I, even will reduce the MTBF and we were having low MTBF, so that yeah, so meantime which will increase. MTTR was high, so it will go down. So operational inefficiencies will reduce and will again build an intelligence layer over this 5G. So all these benefits which we are getting, which is a critical enabler to from a traditional manufacturing shift to autonomous manufacturing.
So what I understand is that the cost of maintaining thousands of miles of cable is basically no longer an option, right? So wireless flexibility provides that now as a financial necessity as well, rather than a luxury, if I'm correct, right?
Because there is no
So,
time, there is no maintenance downtime right now. Our production systems need to be run all the time, 24/7. So only Sunday we get to do all these stuff. So in one day, how you will reconfigure and scale all those things so perfect,
right.
you vital role in that. Yeah.
Plus shift the assembly line also, right? You need to also kind of change the setup from one kind of assembly line to another and so on, right? So Abhijit, back to you. So the total cost of ownership, how do you manage the cost and distribution of these costs? Because what is the timeline to implement and see the returns or return on investment with respect to this timeline, right? So how do you look at this whole automation from that context?
Yes, I think very important question, and I think that is what most of the customers are looking at what is the TCO and what is the ROI, right? Ultimately,
Right.
uh,
TCO,
so,
right? The total
uh,
cost of ownership, yeah.
so when we see that when you have to deploy a private 5G network, there are a few things we have to take care of. As you mentioned, like you can think it about as a small mini Geo or Airtel network within your factory setup. So
Mm-hmm.
you will need all the components more or less, but in a smaller compact form, right? So you need the radios to be deployed, like the 5G radios to be deployed. If it is an indoor, then you would only need indoor small cells, but if it's an indoor and outdoor combination, which is very relevant, I would say, on like ports, then mining, oil and gas, right? All of them have a lot of outdoor area to be covered and a lot of mobility kind of applications running. In the indoor, there you will need a combination of indoor and outdoor radios. Now these radios has to get connected to the packet core network, and that's where we predominantly provide our solution here with 5G core, IMS, etc., and an NMS to manage the entire setup. Then you may also an extension of the 5G network is that you would probably like to run most of the application on-prem, right? Because of safety, security concerns, as well as to ensure that you can do real-time autonomous systems to be running, right? So if you send data to a place which is in a public cloud, it will take again that latency of the public cloud would come in. So you'd probably create a private cloud kind of infra with on-prem AI, etc., within your setup itself to do that. Similarly, there would be some end devices like drones, which, or you can say the robots which are 5G enabled. So you would need 5G module or SIM or CPE to be connected. So these are 4 or 5 ecosystem devices and infrastructure items on the 5G that you have to deploy to create an entire 5G network. So for a typical, like a small indoor deployment, it can cost around 250K USD, but it can, if it's outdoor larger area, it can go higher, like of course around based on the kind of deployment it will increase. So but it can go beyond 500K USD to 1 million. It can be more based on the use cases, but just to show you that, well, like you can do private 5G deployment within 250K or less to based on the size. So it's, when you talk about 5G, it's not that the cost is like really very high. I mean, you can start with something which is around 100K to and beyond, right? Based on the size of the system. The other thing which comes into play is the spectrum cost, which you have to take care. In India, we have to work with the operators to get the spectrum. Railways and you
Yeah.
can say defense have their own spectrum, but otherwise you need to work with the operators. The spectrum cost would come. But if you go to other places outside India, like Europe, like France, Germany, every places you can get a private 5G spectrum for your geolocation
Right.
directly by paying to the government. And
Right.
the spectrum cost is quite very low. I mean, in like Germany, or like for every 1 year, right? In US, you have CBRS. Similarly, in Australia, Canada, there are ways to get spectrum. I think that's one place where we have to do some disruption. I think the total strategy, spectrum strategy in India for private 5G, because we see more and more that it may become a de facto for industrial automation, like Wi-Fi is for residential usage, right? Now, for the ROI, I gave you some idea estimate of the kind of cost, right? When the area becomes bigger, the cost of private 5G deployment will be lower than Wi-Fi, because just to give you an example, if you have to put in a 4 square kilometer area a Wi-Fi, you have to put a Wi-Fi access point every 50 meters. You want to
Right.
cover entire area. So you would
Right.
need more than 400 access point. And then how do you power it? Every 50 meters, can you put a power point and power a Wi-Fi access point? That becomes a thing which is not really easy to manage. It becomes
Fragmenting,
quite
not fragmenting.
fragmented in
Mm.
this case. Whereas when you use private 5G, and because as you know, private 5G, you can it's on the unlicensed band, so you can radiate higher power, you can radiate around 5 watt, right? And you can get a coverage of around an area of around 1 kilometer using one radio. Whereas Wi-Fi, you cannot, because it's on an unlicensed band, you can only radiate in milliwatts, so you can only cover 50. I'm just giving you 50 meters, right? So using only four radios, by 5G radios, you can cover entire 4 square kilometer area. And you may
Right.
have some dead zones where you can put a small cell or anything else, but that's the kind of. So when you see this, the OPEX and the CAPEX cost of Wi-Fi for a 4 square kilometer area compared with private 5G, and what are the kind of benefits you'll get, even cost-wise, you will see that the Wi-Fi cost goes higher, especially when you use solutions that we provide and probably some partner provides. You will probably get a cost-effective solution even compared to Wi-Fi for 4 square kilometer area, and it's quite significant. And the kind of use cases that you can run, as I told, mobility is kind of seamlessly supported. So now coming to the ROI. So we have seen and to the customers where you have deployed, they were not able to communicate or talk between two ends of the factory, which is
That's
a 4 square kilometer area.
mm.
Even such basic things gets enabled, which is very important at this point. I'm not even talking about industrial automation. I'm talking a basic call from 1 kilometer or 2 kilometer between the factory ends, right? It was not feasible. But when you enable that is feasible, you can run a drone across the entire area to do survey. So when you go to the ROI, what we have typically seen is that to incur the cost of like maybe 2.250K or 500K that you have kind of taken, and also the OPEX cost, you will probably take at least 1.5 years to get the ROI. 1.5 to 2 years to get the ROI, provided you start putting the use cases quickly. Deployment time is generally actually getting the spectrum license and also getting the devices, the hardware. It may take around 2 months. Deployment may take 1 month more, and then the use case integration is an ongoing task, but the initial use cases may get integrated within 1 month itself. So typically 3 months is how much it takes the deployment along with the logistics spectrum and getting all the items, right? And then use case is an ongoing factor, but 3 months is a good time for a deployment for private 5. Kind of little bigger deployment itself, not small, like a 4 square kilometer deployment in 4 months, 3 to 4 months. Yes. Sunil, you are mute. You are on mute,
Yeah,
sir.
sorry. So that's a very wide question, wide coverage of this particular question that you share, right from the extension of the 5G to on-premise solutions to having it within a budget of around 250K for a 4 square meter setup, and then you also looked at the direct 5G cost as compared to the spectrum challenges as well. So I think these are some of the things which we'll probably be addressing in the rest of the session as well, because there are a lot of these questions in terms of the spectrum as well. But you mentioned from end to end from the factory. But what about the walkie-talkies and the other setups that they have? Do they have those, or they don't have those setups? Is that in the absence of those that you were mentioning, or even those can be basically integrated into the 5G setup?
Yeah, so
Just to
yeah, it's a very important question because ultimately the use cases kind of drive the ROI, right? So
right.
yes, so all the applications like push to talk, like walkie-talkies, you have 5G enabled. So that is what factories are. In fact, in railways also, where we are working, is being deployed. Similarly, 5G based cameras the 5G ecosystem is coming up. Well, compared to a normal camera, the 5G camera cost would be higher. That's at this point, but as more deployment happens, the cost will definitely reduce. But most of the devices like GPS tracker, drones, walkie-talkies, even robots, AMRs are coming with 5G inbuilt modules. SIMs can be inserted, and you can start running that. So these are available. I mean, the use case cost would, again, if you're it's a brownfield kind of deployment where you don't probably have a SIM, then you have to use a 5G router or a CP to basically connect the brownfield connection to that. In fact, there are some technologies which we use where Wi-Fi can get connected to the 5G network, and be part of the bigger
I'll
5G.
I'll come to that. Yeah, I have that in one of my list of things which I want to ask you folks. In coming back to Saravanan, in terms of the real-time problems from the overall robotics industry that you've seen since FANUC's inception over the last several years, and especially when it comes to the integration of 5G, have you seen anything specific which you would like to highlight,
Yeah, I think,
Saravanan?
yeah, the very specific challenges, no, because nobody's looking at no automating a single machine or things in this current era. So people are going for the complete check, like how our Vibor was also mentioning that. So the number of scalability and number of devices, it's very high. For example,
Mhm.
if you take an automotive plant, the welding robots are there, AGVs are there, inspection systems for AIs are there, CNC machines are there, and they also have their own MES systems also. It's not only
Right.
the physical entities what they look at. So like MES system, so everything communicates in real time. They wanted
Mhm.
a real time communications things over there, and these kind of private 5Gs and things, add a lot of values to it. And also the another challenge, what is, as Vibor was mentioning, the scalability factor.
Mhm.
So tomorrow, for example, we are extending, the production is getting extended into mass production, and you wanted to, increase the production levels, bringing in the robots, putting everything together. It's not a, we don't have a time or luxury to to set it up in the real time manufacturing facility. That luxury is never there. So
Mhm.
things like 5G can help us to scale things in a better. So this solves one of these scalability problem in terms of communication.
Mhm.
That's a very very big gap which we have, and that can also be addressed with these kind of things in a much better way. So in our perspective, the robot itself has always been intelligent. The next step is to enable the robots and machines and AI systems to work together as a one connected entity altogether. That's how we are
Mhm.
looking at, because robot alone as a single entity may not be able to be more intelligent than when you connect to other devices. So it
Right.
needs eyes, it needs things to see, understand, and act like a human. So these things are the major things where we see as a challenge, and these connectivity factors will make a lot of difference into it.
Right, right. I think coming back to the previous question, which Abhijit you had, on like for example, there are a lot of traditional protocols I was just mentioning earlier also. So having been in this industry for a long period of time, and having kind of worked looking at, I've seen this as a fundamental shift from a best effort connectivity to deterministic control kind of setups, which
Exactly.
require high reliability robotics, right? So
Yep.
by leveraging the features within the Niral OS architecture and the open interfaces of the robotic arms, we are finally seeing the implementation gap closing quickly, right? So this isn't just
Yeah.
about faster speeds; it's about the kind of leap from the unpredictable wireless to a software-defined infrastructure that can offer the same reliability as a wired PLC environment from the past, right? So having been this in the architecting the private 5G space and the edge solution since the last 2021 onwards, this is one thing that I've learned. It's that the implementation gap between the industry 4.0 slideware, which used to be there earlier, and then the operational reality has kind of paved the way with some of the failed Wi-Fi pilots also in some cases. But you want to say something, Professor Saravanan, or
Yeah,
yeah?
you're absolutely right. In the current era, what we see now, the physical AI is the one which is
Yes,
transforming
exactly.
the manufacturing
Mm.
sector, and these connectivity plays a very very big role there,
Right,
because everything happens in real time. There
right.
cannot be a latency, and we cannot have a latency there. So these things makes a lot of difference there, and this is the right time where the entire industry is also shifting towards it. They are realizing the actual power of AI putting, because the previous all these years we have been seeing this generative AI making the difference on everybody's life. But for the manufacturing industry as such, if you see the current physical AI coming into picture and changing things, the adaptation is going to be very.
Very quickly, right? So Coming back to the question there, in terms of the connectivity itself, for example, we talked about Profinet, inter-industry protocols, right? Traditional industrial protocols like Profinet, EtherCAT, or some of the others like. We also there are a lot of these which work over the time-sensitive networks, which is one of the features of 5G, right? So we can, when we connect with the existing OS that you have, the private 5G setup, without requiring expensive media converters or addressing processing overheads, etc. So how do you ensure a deterministic low latency and kind of prioritize this critical robotic safety traffic over standard telemetry data that you have, right? So maybe Vibhor, you want to take that, or I'll go to um, Abhijit after you, probably. Yeah.
I think Abhijit can answer.
Abhijit would be better, right? So Abhijit, can you just kind of see where especially the Niral OS private 5G. So how do you look at the traditional industrial protocols like Profinet or EtherCAT or OPC, etc., which are over the TSN, which will require this expensive media converters or additional processing overhead? So how do you ensure this remains deterministic, low latency, and also prioritize this critical robotic safety traffic?
Yeah, I think the very pertinent question and very technical, I would say, because these are the things which are really how the industries are functioning at this point. You mentioned this Profinet and EtherCAT, right? Why are they used in the at this point? These are Ethernet-based solution, Ethernet-based protocol. They work directly on Ethernet, and they do not use any IP layer. They are not using like TCP or IP or
Correct.
they directly work on Ethernet. One of the reason it was done is to enable industries to have deterministic or control connectivity. I mean, being uh, between the and this receiver and the transmitter, they want to have deterministic connectivity, and also the TSN part, as you mentioned, time sensitive networking. They wanted that we are always aware of that time and everything works on those time boundaries, right? So that things have to be done on this. So now, yes, so I mean, of course, 5G, especially private 5G, I think those are also considered as part of the 3GPP. There is a thing called ETH-PDO, which we also support. And in fact, in some of the factories that we have gone or done POCs, etc., they don't have any Ethernet network. It's only, sorry, they don't have any IP network. The entire industrial network is on Ethernet, like VLAN and Ethernet, VLAN 1, 2, and Ethernet. That's it. No IP. There is no IP address for any of the devices. For the OT side, IT side is different. They have it differently.
Right.
But the OT side is totally Ethernet based, right? So, and all this Profinet, EtherCAT, TSN are running on top of that. So 3GPP has a standard, as I was mentioning, which is called ETH-PDU, which supports direct Ethernet packets being sent over 5G, right? And we at Niral OS, we already support those protocols because we saw that the industries need that, and then we got it integrated and we support that. So Profinet, Ethernet, all those protocols, for all those protocols, the 5G, the end devices, starting from the radio to the core, the entire use case, like all the devices which comes to create a 5G infrastructure, has to support that. So let's say your device, like as you mentioned, the machine has a 5G SIM already. Then through the SIM it will connect to the radio. So the radio also has to support ETH-PDU, as well as the core has to support ETH-PDU. And beyond the core, it will directly go to the Ethernet OT, that LAN Ethernet, and then it will get connected to that like the Profinet, the transmitter, for example, or the receiver. So that's how it works. So it's our when we give a profit, like a industry which needs private 5G with Profinet, so we ensure that the radio, the core, and the entire infra which we give to the end customer, whether brownfield or greenfield, supports that Profinet, like the ETH-PDU, which supports Profinet. On top of that, you can support Ethernet, ETH-PDU, TSN. The other part is that you talked about deterministic URLC kind of solution, right? So
Right.
when you do robot, see, there are operations, some of the machine operations which are which has to be guaranteed. and yet it has to be given priority. You may know in 5G there is a concept called network slicing. And when in the
Right.
network slice also you have various priorities like GBR, guaranteed bit rate, and some are video related traffic, some are non-guaranteed, right? So you can give priority. Let's say the robot movement, like when the robot moves, those movements are to be given highest priority because that's kind of decides how the robot is moving at this point. But some of the IoT sensor data need not be given higher priority. So the robotic movement would come in the network slice. So a virtually will create a quality of service QCI with 5QI values, which will guarantee GBR, which will guarantee the bit rate of that robot, like to ensure that the robotic movement always high priority is given to that, right? All data goes. Even if there is a congestion, all the robotic movements will be given higher priority. Whereas the IoT or the video, where even if you lose some data, it doesn't cause much problem, but you need to give high bandwidth to video. For that, you can use a network slice to enable video throughput, which is high bandwidth but did not be even if you lose some data, it is not a problem. So then you will give a network slice of that kind, right, of 5QI value of that. So that way you can segregate traffic which are high bandwidth and which are guaranteed to be given with low bandwidth, low latency, and some which are like IoT device data, which may be really low bandwidth also. So you can guarantee that in Niral OS we support network slicing end to end, and also we can create multiple UPF based on the slices to give higher priority and much more control, right? So those things would enable that. And the last part, which is very important and which I think becomes a very important part of private 5G, is the edge computing. You have to run the application on-prem near the network or near the OT network. You cannot run the data in a cloud. Then after doing all the hard work, you will lose the latency on putting things in the cloud. And there is also cybersecurity risk. You may
Exactly.
have heard that recently there has been ransomware attack in one of the factories. I mean, and it has been happening. I mean, so factories security is very crucial. Low latency is very crucial, and that's where with private 5G edge computing running sovereign data centers or the sovereign cloud on-prem is important. So that's how you can guarantee high TSN and low latency, as well as run all the EtherCAT kind of devices based on the application. So yeah, I mean, we are working more on that. It's I think a lot of things to be done, but yeah, the things are already in progress on that.
Thank you, Abhijit. I think that was a really good coverage of the entire roadmap, the landscape of how this is getting implemented, the context of the ETHPDU, the standards from the 3GPP being used to do that end to end, and also providing edge computing, which is basically the need of the hour in terms of taking decisions on the edge, because with a lot of AI, agentic AI, and autonomous networks coming into picture, the physical AI is also having to also equally shape up and react to it, and then kind of take it forward in terms of how this is getting implemented as well. So I will go to Vibhor in terms of how does this combination of private 5G, AI, and digital twins help manufacturers move from reactive maintenance to predictive and fail-safe operations, right? So I think that is something which has been around for some time, but it's all the more required, more than a luxury. Like I said, it is basically required as a primary requirement. So how do you kind of look at this aspect of it from a private 5G, AI, and digital twins to help the manufacturers, especially companies like Bajaj, which are implementing some of these?
This is the biggest challenge which all the companies are facing is the breakdowns or the reactive maintenance. Still, the approach is reactive, where any breakdown occurs and the people go in firefighting mode. So everyone is talking about building a digital twin. Everyone is talking about something predictive maintenance, but where 5G plays the role is kind of the backbone of all this intelligence layer. So when I'm talking about intelligence layer, it basically consists of these four layers where we have sensing ability, predicting ability, then prescribing and making it finally autonomous. So to eliminate this traditional approach of firefighting and reactive maintenance, this predictive maintenance comes in picture, which basically is seeing the entire health of the factory in the real time. So what private 5G is providing, it is providing the low latency and synchronized data flow that allows AI and digital twins, the intelligence layer, to detect the failures early, identify the root causes accurately, and eventually enable the system autonomous and self-healing manufacturing operations. So these are the benefits which are getting in building the intelligence layer, in building the predictive maintenance, in building the digital twins. So when I was saying this sense, predict, prescribe, and autonomous, all these four layers need to talk to each other in real time in very low latency. Then only you can build a perfect digital twin, a perfect autonomous layer. So like for sensing, we have those IoT sensors which sends the data from the physical world. For predicting, we have digital twins where once the data is coming in real time, the digital twin is functioning in real time to tell what is going to break down to break, and what is going wrong with the robots or any machine. Then we have a prescription layer. In prescription layer, where we have, after digital name, we have a physical AI comes in picture, which actually tells you, prescribes you, that decides on the fly that what's to do in real time. And finally, the autonomous act layer. In act layer, the final hardware of robots and hands comes, which finally perform the motion. So this way, the whole ecosystem of intelligence layer is being built uh, to remove that traditional reactive maintenance approach, to build some intelligence over those things using 5G as a backbone. So this shift is happening. This is real, and this is required. This will be required by all the industries in whichever domain they are. Yeah.
Right, because I think this physical AI is very, very crucial at this phase and window, as we see from the bell curve perspective. It is still on the left side of the bell curve, but I'm sure things will move forward very quickly, because it's for those of you who are not familiar with physical AI, it's basically defined as the integration of artificial intelligence into physical machinery and enabling the robots and the autonomous systems to kind of perceive, reason, and then interact with the real world in real time. And kind of it introduces the possibility that you have large uplink videos or that sort of physical AI related videos which have a lot of strict latency requirements, which can become the key part of the traffic, right? So you're basically creating a design challenge there, and you're also creating a monetization opportunity, right? So both of these have to come together, and how you're basically relying on the low latency videos to enable real-time control, for example, right? So some of the typical applications or use cases could be kind of remote supervision of the robots, or supervision of them. So those require like kind of less than 50 milliseconds of effort. And then there are like, sensing and avoiding augmentation, especially when you're running drones and so on. So those especially require like less than 40 milliseconds or so as such. And then you have an overlay rendering, motion aspect as such, right? So those will also be having like less than 20 milliseconds and so on. And then there is a lot of cloud related stuff which will also require like anywhere between, you're doing cloud based assist or cloud inference assisting services, you'll probably require like 20 to 50 milliseconds as well. So these are some of the publicly available reports which you can possibly look at in terms of the physical AI as such. But coming back to
Like, so just add
the
on the physical, yeah, just little bit on that. So like,
yeah,
why
yeah,
this term is going very popular, and in
right.
terms of, like, we all are seeing how many humanoid robots are coming in, and
Yeah.
many of them.
Number of companies also doing that, right? Yeah,
What is every robotic company, what is trying to do is to close and bridge the gap between a human and a robot. So to
right.
that intelligence of a human inside a robot, and this
Right.
intelligence is what we're calling it physical AI or physical common sense. Like, we
Right.
have done lots of programming, simulation, logics, everything has been done on the robots, but now it's the time where the physical common sense, by common sense what I mean, when a child picks and places the part, he doesn't calculate the coefficient of friction or and the weight of the part, but
Right.
those things were missing in the robotics. Those physical awareness was missing in the robotics. When an operator fixes a connector, he doesn't calculate the force and the inertia and the gravity. So all this physics, when comes in the picture in the robotics, is making robotics now more interesting, bridging the gap between a human and a robot. And that all is possible now through physical AI. So which is the real form of autonomous in terms of robotics, if I can say so.
Absolutely. I fully agree with you, Vibor, because I think there we have is in terms of the cost of supporting this physical AI also, and the traffic which will require changes which will happen at multiple levels. For example, you will have changes at the service level, at the networks level, the application level, or the application models of these, right? So the application level, etc., you require not all the video feeds will be delivered with the same level of urgency as such, right? So at the network level, you have to maintain the quality of service or the
all this
latest
to happen,
processing.
private 5G is the backbone. Nothing
Yeah,
can happen.
exactly. And coming back to that, coming full circle there. So, and then the service and monetization aspect in terms of the latency aspect. Right? So, over to you, Saravanan, because as we move away from this monolithic proprietary OEM systems, how does this disaggregated approach change the TCO for enterprises that are kind of tired of being locked into a single vendor, expensive hardware roadmap as such, right? So, is there anything happening in that front from a open APIs or open interfaces as such from the context of FANUC and the
Right.
other players in the market?
Now everybody has to make open source, or else they're
Mhm.
no longer going to be in the race now. So
Right,
because generative AI is and the development of infrastructure which has been happening right now, if
right.
you're not open enough to know make people build above that, you're not going to be there in the race at all. So we have made a lot of things. So Fanuc in fact has been one of the closed loop systems in the entire market. So we started
Mhm.
building our systems on open systems right now. So for example, if you take it on ROAS, if you're going to ROAS, or if you're going to for Omniverse, RiseXM, things like that. So we started getting into that phase of it, and we very strongly foresee that things are going to change in a different way. That the total cost of ownership and the investments and the we call it as ROI generally in the manufacturing facilities. So these are going to change. The definitions of these things are going to change now, because traditionally we calculate based on how many number of parts are produced or things like that. So generally things are calculated, but now
Mhm.
people are slowly realizing on what are the other efforts which are coming into place for producing those parts.
Mhm.
So you need to have a skilled person to know, come in, program it, evaluate it, inspect it. So now if you are going to enable, like how Vibor was saying that, so we are enabling the robots know to think, act, and know, see like humans. So
Mhm.
that brings in a lot of things which we are going to invest on it. And
Absolutely.
the scalability part of it, once one robot is learned and you wanted to bring it into multiple levels, multiple layers building above it, it's much easier now. In the traditional automation or the robotic systems, these things are not even, they cannot even imagine those things in those traditional systems there. So basically these things are changing the way we see the entire industry itself. That's actual truth. If you are not going to accept that there is a change happening, or there is no conventional way of doing it going forward. So things are not going to be the same anymore. So the total cost of ownership is going to have a new definition in the future.
Mhm.
Correct?
Right. I fully agree. So I think coming back to Abhijit, so we talked about the interfaces, we talked about things. So for countries like India, in terms of the planning, in terms of large scale smart manufacturing, etc., and so on. So what deployment models do you see or do you recommend to balance safety, spectrum, constraints, and cost? Because we didn't talk about the safety aspect so much, or the security aspect, but we can probably come to that in a minute. But what do you see there in this space for the countries like India, which are planning large-scale smart manufacturing zones? What deployment models are more likely? Is it MNO hosted? Would it be private, captive, non-public networks or hybrid networks? How do you see this, and how do you balance the safety aspect, the spectrum constraints, and the cost aspect? I think you covered some of it already, but maybe you want to just quickly wrap up on that.
Yeah, I think there are a couple of like private 5G can be used in a different kind of ways, I would say that one is the industrial and the logistics sector. In the industrial, you have the manufacturing plants, oil and gas mining, all of them coming. In the logistics, you have ports, airports, railways, logistics. Then you have defense as a sector. I mean, these
Right.
are the sectors where you can use disaster management, police, they fall in that sector. And then you also have a sector which is outside India, but even in India it may be bigger, is rural, because a lot of places
Mhm.
rural connectivity is not great, especially with the operators network, right? I mean, if you see private 5G as such, it's not about monetization of the private network. It's about how do you bring ROI for your existing work, right? So which kind of fits very well for you can say industrial sector, logistics, most of them. and also defense, because defense, private secure network becomes very important, right? Defense railways have their own spectrum. You have 700 megahertz spectrum, but on that spectrum, private 5G, if you see, mostly it's on N78 band, which is
Right.
3.5 to 3.8 gigahertz, right? And
Good.
on its periphery, some other band. So whereas if you use 700 megahertz spectrum, you can get a larger range. Because the frequency is low, you can have a higher coverage, but the speed you cannot get high because of the lower frequency. So if you want to get around 700 megahertz to 1 Gbps throughput, you have to come to N78. But let's say
Mhm.
you want to have a large coverage, like 3 kilometer coverage, you may not, N78 may not be suitable, then you need kind of N28. Like, so it's good for that kind of use case, which you don't need high bandwidth, but maybe large coverage, like in mining, for example, right? Or similar disaster management can be another use case for that. So we have to figure out which kind of way, based on that, we have to use the spectrum. But very importantly, especially countries like India, where I see that I was surprised, like 2 years back, we used to tell people about using spectrum or private 5G, trying to kind of help the ecosystem understand the importance of private 5G. But if I look last from October of last year, now industries are coming to us. They realize that private 5G is very important. I mean, of course, I mean, very traditional, even PSUs, right? Mining, ports, oil and gas, most of in India are controlled by PSUs, right? They are looking for a change because everybody needs autonomous system or some level of digitization to start with. Every manual is not working, and when you want to automate anything, when you want to collect the data, you have to connect things, right? So when people talk about I mean, we talk AI industry is going, chip industry is going big, RAM, etc. But I think ultimately to do that, you need connectivity, like to enable that, right? So to do bring the data to process it, you need a great connectivity solution. So I think through that AI, I think connectivity will also get a boost, which we don't realize, but it is happening in the background. Same thing here, even in the industrial revolution, I think connectivity plays an important role. And the spectrum, I think in the government, we are trying to work with the government, but you need to do what Europe has done. You need to give spectrum for the industries, because that's where things are getting slow based on our kind of 3 years of experience in commercialization. Everything is done. The ROI is fine. We can show the ROI less than Wi-Fi also, as I was telling, in bigger deal. But when it comes to the spectrum is where we are getting stuck, because the spectrum clarity, you need to depend on the operator, right, to get the spectrum. I think having a direct spectrum in a band is very important for a country like India, and who is looking for digitization and kind of automation of the industrial automation, right? It becomes very important. Whereas that, I think, is one single most important step from the government as a strategy that should do, is that open up a spectrum like in France, Germany, right? And at a lower cost. You cannot put a very high cost for the spectrum, because it's for a specific geography use, and it's for the automation of the industry, right? It's
Right.
about building locally and selling it globally. Like that's what the industries are doing, Bajaj, and building locally. And so you need to enable them to increase their productivity, and for that you have to give the spectrum at a lower cost. We should do that. That has to come in. It cannot be operator driven, because see, operator driven, I mean, you talked about the other model like MNO driven. A network
Right.
slice can be used by the MNO. See, I mean, while we talk, there has been cybersecurity attacks across, even in India. It is being happening, right? Ransomware attack and other attacks. If you use a public network, that security attacks can happen anytime, because you are connecting to a public network.
Exactly.
I'm not even going to the latency and the real-time nature, because you can run the application. Security is so important. When your energy plant, people are talking about putting private 5G nuclear power plant. We have already deployed in thermal power plants, right? If there is an attack from, I mean, outside, like countries, neighboring countries, they will try to sabotage your energy plants, because then
Correct.
you will lose power. All your
Right.
industry will go for a toss, right? Because there is no
Right.
power. So if you want to use public network, I don't think that's the right
It's
way
an
of
option at all. Yeah,
it's
definitely
mission
not an option.
critical infrastructure should be independent, autonomous on their own, and sovereign. So computing, networking, storage, everything should be sovereign for them. It cannot
Right.
depend on public infra, which can be used to do an attack, cyber security attack. Now the other part, of course, we have already discussed the latency, high reliability, TSN. You cannot do on a public kind of network and guarantee those things that Beaver was talking about, digital twin or autonomous system. You would need real-time connectivity with TSN, everything, which would need it to be, having such a system. Yeah, I think.
Right. And I think very quickly to Saravanan. So these machining cells are typically very dense with heavy steel in your factories, which you have. So there's moving gantries. There are gantries which move, and there are like high frequency motors that create multipath fading and also severe EMI, electromagnetic interference, or for Wi-Fi, etc. So how does this private 5G handle these sort of industrial environmental barriers, and what does the physical infrastructure kind of look at inside of a machining shop, deployment inside of a machining shop look like? Maybe we can just quickly go through that, and in the interest of time we can just wrap it up also subsequently with Vibor.
See, in the industry machinings, if you see, yes, there are a lot of challenges on that because, as Guru was saying, we cannot have cables running everywhere. So that's
Mm-hmm.
a huge challenge what we have. And when there is a cable running, we have to have a dedicated lines for the interfaces and the communication things as such. Because again, there was also, as I told you, there were electrical noises and things which creates a problem as well. Sometimes we struggle to understand that there are production cases where because of noise the signal is being delayed and there is an accident to it. That's also a case which happens there. So this is very very critical, the two in terms, if you see on the safety signals, we cannot compromise on those things. So that's area where we have a lot of things. And when we tested during this white paper of the POC, when we did it, so we also did test it for some of the safety signals as well, like for example the emergency signals and things like that. Why? Because as you rightly pointed it out, in the shop floor environment, in the real time industrial case, maybe if we see the shop floors of no other countries, things can be different. But again, for the industrial environment of India, we pretend to India, what we are seeing it right now, it needs lot of discipline to have it over there.
Right.
So that's very very what to say, if you are going to go to a conventional person of a machining shop telling him to change it, it's not practically easy for him to adapt to it very quick. So in those areas is where we see this kind of systems can play a very major role. We see a lot of differences and a lot of value addition as such which can happen to the real world environment there.
Right. Thank you, Sarvan. I think we run out of time, but I'll just leave this one last question before we wind up. If there are any audience questions, maybe Tanmay or someone, we can just let me know. But Vibor, closing with you. So what does a truly autonomous factory look like in the next decade? So what role will private 5G, robotics, and digital twins and the physical AI play in making that vision a reality? I think you covered most of it, but maybe we just like a two-liner uh, from your side, a quick bite.
Yeah, I'm Paul Dayanidhi. I would like to ask question to Abhijit Chaudhary. See, we
Yeah,
have got broadband service available across stations. I have
right,
implemented through Railtel from Bombay Central to Belapur. And
right,
I've got the award for Bombay Central, from Central Bombay to Bombay Central I've done. My
right.
question to Abhijit Chaudhary is, how do you convert these station broadband servers into a private 5G? Because there is, to be frank and honest, my father was in railways. Every station has got fiber coming under the track. You should be knowing it. And the bandwidth is available. Your talk on low latency, all those things will not affect, will not come into, will not have any undisturbed this one for the services that is being invoked by the customer. So how do you convert the station broadband service to a private 5G? And see, even I have spoken to the present railway minister, who was also a communication minister when
Mhm,
he was handling both. Why you are not giving spectrum to railways? Because my father
mhm,
was in railways. I from that salary only I studied up. I got my
mhm,
degree and all these things, my PG and UG and IIT Bombay and all these things. So I have utmost faith on railways. I had one person, Rajshekhar, he's ADG, and now he's retired on May 31st. I also told him the entire logistics of railways can be connected via private 5G. With even the station broadband can be converted. I don't know how you take it up, because I am not a, my father is no more in railways, he's passed away. But how you being an Abhijit Chaudhary, being in from the Niral
Yeah,
network,
we
how
get
do
the
you take
question.
it with the minister? That's
Could you get your full name? P. Daya, is it?
Paul Dayanathy. Paul Dayanathy.
Paul Daya. Okay, yeah. Abhijit, you want to take that?
Yeah,
Yeah,
Abhijit
I
will be the
can.
right person, since
Yeah.
he's on the this one, and he has
Correct.
also told that with the existing Wi-Fi you cannot have logistic movements of the railways and all. And railways have invested so much. Though Google was the back, this one they had only provided cables and this one routers, Cisco routers, because I have implemented it.
Okay.
It's a Cat6 cable and this thing. The entire investment was done by railways because bandwidth was provided through fiber. So that is there the cost plays a role. So
Yeah.
my
So,
honest
yeah.
feedback from Abhijit Chaudhary. That's what.
Yeah,
Thank you
so thank you so much for
for the
the
question. Yeah.
question. Yeah, hopefully you can hear me. So
Yeah, I am able to hear you.
yeah, so we are actually doing one work with railways, exactly what you mentioned, private 5G, or you can say 5G for railways. It is India's first 5G for railways. We are doing it in the Mathura Palwal section at this point. We, with one or two of our partners, we are doing a 5G for railways. Currently, we are doing it for a 30-kilometer stretch, but it will get then extended to 100, 200 kilometer and beyond, right? So what has we are doing there is that currently they are using for their own consumption railways. So it is basically across the railway track. The 5G towers are being put so that across the railway track, all the railway coverage or then push to talk applications, right? All of them, the push to talk that we talked about, the walkie talkie kind of thing, which the railway employees uses and through which they talk to the station or cab to station from the railway train cab railway to the station communication or station to station communication within the 30 kilometer they are using 5G as a communication mode, and we have put one like the packet code etc, and we have deploying around 19 radios to cover that 30-kilometer stretch with redundancy. Let's say one radio, like you are in a place where you will get always two radio connectivity. So if even if one radio goes down, you will get connectivity from the other radio, because railways again is a mission critical infra. That's how they are doing the pilot, and they want to extend that POC beyond. So this is kind of an example of what is already happening. In fact, this solution is on 5G. I won't say it's a private 5G, but railways own 5G. So, and it
Yeah,
is being done in the 700 megahertz spectrum. And in 700 megahertz spectrum, because it's the lower end of the frequency.
Lower the frequency, higher than this one. That's I know
Yes,
that
yes.
because
So
I'm
that
a communication man. So I've implemented 3G, 4G in Reliance and all. So okay.
yes.
Go
So
ahead.
we discuss more on that. I mean, if you can share your email on the
We
WhatsApp.
can.
Yeah,
Yeah.
dayanathipal@gmail.com. That is available. dayanathipal@gmail.com.
Okay, okay. And you.
Are you in touch with Radhakrishna Ganti, who has set up a 5G lab for railways in Secunderabad? He through IIT Madras. You get touch with him. Radhakrishna Ganti, you know, he's a 5G lab in IIT Madras. He has we have set up a 5G lab in Secunderabad. Rajshekhar was there. He was ADG. Now he's retired. My May 31st, one person from I think Jharkhand has taken over. If you are, if you know him, you get connected with him, because I advised him connect. I told him from IIT Madras, connect entire your logistics via 5G project. That was my honest advice, because my father was in railways. So I have the utmost faith that salary through which I gained the degree should go back to railways. That's all.
We understand. Thank you. Thank you for sharing that. I think this is a very good question. So I think the other aspect about the 5G setup itself is in terms of the infotainment inside of the train, for example, the operational safety aspect, the real-time vehicle status detailing, the passenger experience, the real-time train control, etc., and so on. So we have all of these as such in many of the other countries, but we also need to bring it back in terms of the LTE for railways and also the FRMCS for the future rail mobile communication services in India. For example, you have communication-based train control, you have CCTV cameras and safety applications, mission critical applications, and then the passenger entertainment, like I mentioned, right? So back to Vibhor, would you want to kind of wrap up the last one, or can we just skip this one in the interest of time, on the truly autonomous factory outlook for the future in the next decade?
Yeah, if I can conclude all, because we already talked about all
Yeah,
the
yeah.
also.
Just one-liners from all three
Yeah,
of you.
so
Yeah, all three of you. Yeah.
I would say, like, if in a very layman terms, private 5G will act as a nervous system of the body. Digital twin will be the brain. Physical AI will be the decision maker, and finally, robotics and the hands will be the executor. So when all these things will gel up together to sense, to think, to simulate, and act, which is the future of all the manufacturing industry. And very soon, what all organizations have started building the foundation now with private 5G, AI, and digital twins will lead the next era of manufacturing. So it's not the future thing, it's the present thing now, and everyone should start adapting as soon
As
as.
of yesterday, not today. As of yesterday. Yeah.
Yes.
So over to you, Saravanan. Maybe one line from
Yeah,
you
that's
on this.
it's no longer a future factory. It's a current factory. What we are trying to build here. It's,
Yeah.
it's no longer that future factory.
Yeah.
Everybody starts adapting to it, and yes, I think the Indian market, Indian industries are also marching towards it.
Right. Because I'm talking more about autonomous and fully decision
Yes.
controlled as such. But Abhijit, you want to just add a couple of
Yeah,
lines there?
I mean, I just wanted to create one thing. The total cost of ownership on private 5G when the size becomes bigger is lower than Wi-Fi. So, I mean, the cost is what everybody thinks about, but just go into the book, start doing the maths. We can work together, but that's true. The TCO of private 5G is actually lower than Wi-Fi when the size becomes bigger, and on top of that, the ROI you will get much quickly. So that's how I would like to end with. Thank you so much.
Yeah. Thank you so much. I think that's reality check of the ROI in terms of the cost factor, the metrics, the result, etc., and so on. So you need to look at it from a 5-year TCO analysis. You definitely have like 22% lower TCO compared to Wi-Fi, etc., 6E Wi-Fi standard. Basically, the setup and capex aspect, the initial investment versus the legacy aspect. You'll probably look at 81% of the enterprises report lower setup costs as they adopt this approach. And then the downtime prevention in terms of predictive maintenance impact, you'll see 25 to 30% reduction in the unplanned downtime. And then the payback period also in terms of the time to measure or measurable ROI, you'll probably see an 87% of enterprises which see ROI in the less than 12 months. This is coming from multiple sources, multiple analyst reports, etc., and so on. So to closing remarks, to conclude, it's very clear that in 2026, in the next is the 12 month or the next 6 months tipping point, and we are no longer kind of debating whether private 5G is real or and we are pre-calculating how fast it kind of pays for itself. So with, like I said, with 80% of the industry seeing a full return on investment in under a year, the question for every CXO, CIO, etc., and also all the implementation operational heads in this call and other players in this call. So can you afford the best effort limitations of legacy wireless for another financial cycle, or do you want to move to private 5G? So with that, I would like to kind of close on this, from Edge AI at the grid edge, the implementation statistics that I just shared, and then the digital twin and the 5G adoption for private 5G. So thank you so much. I really appreciate the audience who have been very patient. We took some extra 14 minutes. We apologize for the extended time, but thank you so much, and it was a wonderful discussion. And with that, we'd like to wrap up this webinar. And I think the key takeaways from you would definitely be in the areas which we had actually already highlighted in terms of clear decision framework, a reference architecture, and then the latency, throughput, and uptime, and also the implementation aspects of it. Right. Thank you so much, Abhijit. Thank you, Vibhor, and thanks everyone for being with us.
You are excellent. Yeah. Your presentation was good, up to the point. That's my honest opinion from my heart. Abhijit Chaudhary and Saravanan. Thanks.
Thank you. Thank you, Paul. Thank you for that.
Thank you. Thank you all.
Take care.
Have a good day.
They have,
Good day to you.
yeah.
Take care.